Welcome to InstaLearn AI. Let's start our Microsoft Machine Learning Operations Engineer Associate AI-300 exam-style Q&A series. Here's question 1. Question 1. You manage an Azure Machine Learning workspace, and you develop a machine learning model. You must deploy the model using a low-priority VM to take advantage of a pricing discount. Which deployment target should you choose? A. Azure Container Instances, or ACI. B. Azure Machine Learning Compute Clusters. C. Local deployment. D. Azure Kubernetes Service, or AKS. Think before you answer. The correct answer is B. Azure Machine Learning Compute Clusters. Here's why. Only Azure Machine Learning Compute Clusters support low-priority VMs, also known as spot VMs. These VMs offer significantly reduced pricing because Azure can reclaim them when capacity is needed elsewhere. Question 2. You create a binary classification model. You use the FairLearn package to assess model fairness. You must eliminate the need to retrain the model. You need to implement the FairLearn package. A. FairLearn. Reductions. Exponentiated gradient. B. FairLearn. Pre-processing. Correlation remover. C. FairLearn. Reductions. Grid search. D. FairLearn. Post-processing. Threshold optimizer. The correct answer is D. FairLearn. Post-processing. Threshold optimizer. Here's why. Exponentiated gradient and grid search are FairLearn reduction methods that require retraining the model with fairness constraints. Correlation remover is a pre-processing technique that modifies features before training. Since the data changes, the model must be retrained. Threshold optimizer, on the other hand, is a post-processing algorithm. It works by adjusting the decision thresholds on the predictions of an already trained model to improve fairness across different groups. Because it operates on the model's outputs rather than the training process itself, there is no need to retrain the model. That's exactly what the question requires. Final answer is D. FairLearn. Post-processing. Threshold optimizer. Question 3. A retrieval augmented generation (RAG) solution returns incomplete answers because relevant content is inconsistently retrieved from the knowledge source. You need to improve RAG accuracy without changing the embedding model currently in use. You need to achieve this goal while minimizing operational costs. Which two actions should you perform? Each correct answer presents part of the solution. Note: each correct selection is worth 1 point. A. Tune chunk size and overlap to match content structure. B. Implement an optimized re-ranker. C. Increase token limits for all requests. D. Optimize embedding vector length. Correct answers are A. Tune chunk size and overlap to match content structure. B. Implement an optimized re-ranker. Here's why. Adjusting chunk size and overlap ensures that context is preserved during retrieval, improving recall. Adding a re-ranker refines retrieved results by scoring relevance, boosting accuracy. Increasing token limits, C. Raises costs without fixing retrieval quality. Optimizing embedding vector length, D. Requires changing the embedding model, which is not allowed. Question 4. You need to recommend an experiment tracking strategy that ensures consistent experiment results. What should you recommend? A. Azure Machine Learning Job Output Logs. B. MLflow Experiment Tracking. C. Application Insights Logs. D. Azure Monitor Alerts. Correct answer is B. MLflow Experiment Tracking. Here's why. MLflow Experiment Tracking provides a structured way to log parameters, metrics, artifacts, and results, ensuring reproducibility and consistency. Job output logs, application insights, and Azure Monitor Alerts are useful for monitoring and diagnostics but do not guarantee consistent experiment tracking. Question 5. A data science team completes multiple training runs within an experiment by using MLflow. The team wants to store a selected model in Azure Machine Learning so that it can be versioned and deployed later. The model must be versioned centrally for reuse across environments. You need to version the trained model. Which two actions should you perform? Each correct answer presents part of the solution. Note: each correct selection is worth 1 point. A. Locate and capture the model artifacts from the outputs of the training run. B. Register the model in the Azure Machine Learning workspace. C. Tag the training experiment with a name. D. Export the model files to local storage. Correct answer are A. Locate and capture the model artifacts from the outputs of the training run. B. Register the model in the Azure Machine Learning workspace. Here's why. First, identify and capture the model artifacts generated during the MLflow training run. These artifacts contain the trained model files that need to be preserved. Next, register the model in the Azure Machine Learning workspace. Model registration creates a centralized, versioned model asset that can be managed, reused, and deployed across different environments. Question 6. An organization validates generative AI applications during CD Microsoft Foundry. Evaluation must run automatically and block releases when quality thresholds are not met. Manual evaluation is no longer acceptable. Evaluation must use both predefined quality metrics and custom safety checks. You need to implement an automated evaluation workflow that supports both built-in and custom metrics. A. Enable application tracing to collect runtime telemetry. B. Review evaluation results manually after deployment. C. Monitor latency metrics during model inference. D. Implement an evaluation step by using GitHub Actions. Correct answer is D. Implement an evaluation step by using GitHub Actions. Here's why. GitHub Actions can integrate automated evaluation into the CI/CD pipeline. This ensures predefined metrics and custom safety checks are run automatically. Releases are blocked if thresholds are not met, eliminating manual review. Other options, A, B, C, provide monitoring or manual validation but do not enforce automated blocking in CI/CD. Question 7. You need to isolate training workloads while remaining cost-aware to address Fabricam Inc.'s issues, constraints, and technical requirements. What should you implement? A. Training jobs on a single shared compute cluster. B. Fixed-size compute cluster. C. Dedicated compute clusters per experiment. D. Managed compute targets with autoscaling. Correct answer is D. Managed compute targets with autoscaling. Here's why. Autoscaling managed compute targets isolate workloads while automatically scaling resources up or down, keeping costs under control. Shared or fixed clusters, A, B, risk resource contention and higher costs. Dedicated clusters per experiment, C, ensure isolation but are expensive and not cost-aware. Question 8. An organization is deploying several generative AI workloads by using Microsoft Foundry. Each workload must meet different requirements related to data governance, task specialization, and operational cost control. The organization requires models that meet the following requirements. Model behavior aligns with the task being performed. Data handling aligns with internal governance policies. Operational complexity and cost are justified by workload needs. You need to select the foundation model options that meet the requirements. A. A model optimized for conversational reasoning when deploying an interactive assistant. B. The largest available model to simplify operational management. C. The smallest available model to minimize the usage cost. D. A model that supports multiple input types when workloads require combined text and image analysis. E. A model that offers enterprise governance controls when workloads process regulated business data. Correct answers are A. A model optimized for conversational reasoning when deploying an interactive assistant. D. A model that supports multiple input types when workloads require combined text and image analysis. And E. A model that offers enterprise governance controls when workloads process regulated business data. Here's why. A. Choose a model optimized for the task, conversational assistant. Microsoft recommends selecting models based on workload fit, not size. D. If the workload requires text plus image analysis, choose a multimodal model that supports multiple input types. And E. For regulated business data, choose models and deployments that support enterprise governance and compliance controls. Question 9. A team develops and manages a conversational assistant by using Microsoft Foundry. The team must be able to validate that the assistant does not produce hateful responses before the application is exposed to any users. You need to evaluate the model output for hateful responses as part of a repeatable validation process. Which evaluator should you configure first? A. Protected material. B. Groundedness. C. Indirect attacks. D. Content safety. Correct answer is D. Content safety. Here's why. The requirement is to ensure the assistant does not produce hateful responses before release. In Microsoft Foundry, the Content Safety Evaluator is specifically designed to detect harmful content categories such as hate and fairness, violence, sexual content, self-harm. Therefore, it is the appropriate evaluator for validating hateful outputs. Question 10. An Azure Machine Learning workspace contains multiple registered versions of a model that is used in production. An older model version must no longer be deployable, but it must remain available for compliance review and potential rollback. You need to change the state of the model version to meet the requirements. What should you do? A. Archive the training dataset for the model version. B. Delete the model version. C. Archive the model version. D. Unregister the model version. Correct answer is C. Archive the model version. Here's why. Archive model version means keeps the model available for compliance and rollback, but prevents deployment. Delete or unregister means removes the model, making rollback impossible. Archiving the training dataset means does not affect deployability of the model itself. The right action is to archive the model version. Question 11. A team is deploying machine learning models to a production inference endpoint in Azure Machine Learning. The team requires a safe way to validate a new model version without disrupting existing users. You need to recommend a deployment strategy for controlled testing of a new model version. What should you configure? A. Traffic splitting between deployments. B. The model asset version in the registry. C. Deployment to a separate staging endpoint. D. An evaluation script in Azure Machine Learning. Correct answer is A. Traffic splitting between deployments. Here's why. Traffic splitting allows routing a percentage of live traffic to the new model version while the rest continues to use the stable version. This enables safe validation without disrupting existing users. Model asset versioning. B. Only tracks versions, not deployment strategy. Staging endpoint. C. Isolates testing but doesn't validate against real production traffic. Evaluation script. D. Helps testing but doesn't control deployment traffic. The best way to validate safely in production is traffic splitting between deployments. Question 12. Hotspot. Question. You are monitoring a fine-tuned large language model deployed in Microsoft Foundry. You evaluate the model before and after fine-tuning using the same evaluation dataset. You review the following evaluation results. Groundedness score baseline 0.82, fine-tuned 0.91. Relevance score baseline 0.85, fine-tuned 0.88. Hallucination rate baseline 0.06, fine-tuned 0.05. Response latency baseline 420 milliseconds, fine-tuned 430 milliseconds. You need to evaluate the following statements and select yes or no. Statement 1. The fine-tuned model shows improved grounding compared to the baseline model. Statement 2. The fine-tuned model introduced a regression in hallucination behavior. Statement 3. The fine-tuned model's response latency indicates a functional failure. Statement 4. The evaluation results indicate that fine-tuning improved overall response quality. Correct answers are as follows. Here's why. Statement 1. Yes. Groundedness improved from 0.82 to 0.91, indicating better grounding and responses. Statement 2. No. Hallucination rate decreased from 0.06 to 0.05, meaning hallucinations improved rather than regressed. Statement 3. No. Response latency increased slightly from 420 milliseconds to 430 milliseconds, which is not significant enough to indicate a functional failure. Statement 4. Yes. Overall metrics improved in groundedness, relevance, and hallucination rate, indicating better overall response quality despite a minor latency increase. Question 13. Drag drop. A team runs training jobs by using multiple Azure Machine Learning pipelines. The team must ensure that all runs use the same Python packages and system libraries. The solution must allow dependency updates to be versioned without modifying training code. You need to configure the workspace so that runtime dependencies are consistent and reusable. Which 4 actions should you perform in sequence? To answer, move the appropriate actions from the list of actions to the answer area and arrange them in the correct order. A. Store dependency versions in a configuration file. B. Define the required dependencies in an environment specification. C. Register the environment in the Azure Machine Learning workspace. D. Reference the environment in training jobs and pipelines. E. Modify training scripts to install required packages at runtime. F. Create a new version of the environment when dependencies change. Correct answers are A, B, C, D. Here's why. The requirement is to ensure consistent and reusable runtime dependencies across Azure Machine Learning pipelines while allowing versioned updates without changing training code. The correct approach follows the standard Azure ML environment lifecycle. A. Store dependency versions in a configuration file. This captures exact package versions so environments can be reproduced and updated in a controlled way. B. Define the required dependencies in an environment specification. This is where you formally declare Python packages and system libraries using a Conda or Docker-based environment definition. C. Register the environment in the Azure Machine Learning workspace. Registering creates a versioned, reusable environment asset that can be shared across pipelines and jobs. D. Reference the environment in training jobs and pipelines. This ensures all pipeline steps consistently use the same registered environment, guaranteeing reproducibility and consistency. Question 14. Drag drop. A company is standardizing generative AI development across multiple teams. Each team requires an isolated workspace. Governance and shared connections must be centrally managed. You need to implement a Microsoft Foundry environment structure that supports centralized governance and team isolation. Which configuration should you use for each requirement? You are given the following configuration options. A shared Microsoft Foundry project. A shared Microsoft Foundry resource. A Microsoft Foundry project per team. A Microsoft Foundry resource per team. Requirements to map. Isolated workspace for each team. Security and governance across teams. Correct answers are isolated workspace for each team, a Microsoft Foundry project per team. Here's why. A project provides the workspace boundary for development, so creating one per team ensures proper isolation while keeping work separated at the team level. Security and governance across teams, a shared Microsoft Foundry resource. Here's why. The resource acts as the central management layer where security policies, networking, and governance controls are applied consistently across all teams and projects. Question 15. A financial services company is deploying Microsoft Foundry to host generative AI workloads that process regulated customer data. The Microsoft Foundry environment must prevent any public network exposure while still allowing services managed by Microsoft Foundry to communicate with dependent Azure resources. Security auditors require that all traffic to and from the Microsoft Foundry resource remain on private networks, with no public endpoints available. You need to configure the Microsoft Foundry environment so that network access is restricted while maintaining full platform functionality. Which two actions should you perform? Each correct answer presents part of the solution. Note: each correct selection is worth 1 point. A. Configure a managed virtual network for the Microsoft Foundry resource. B. Use API key authentication for all model endpoints. C. Deploy the Microsoft Foundry resource in a separate Azure subscription. D. Disable public network access to the Microsoft Foundry resource. E. Disable all inbound network access. Correct answers are A. Configure a managed virtual network for the Microsoft Foundry resource. D. Disable public network access to the Microsoft Foundry resource. Here's why. Managed virtual network, A, ensures all communication between Foundry and dependent Azure services happens privately, without public exposure. Disable public network access, D, removes public endpoints, enforcing private-only traffic. Other options. B. API keys, controls authentication, not network exposure. C. Separate subscription, provides organizational isolation but doesn't enforce private networking. E. Disable all inbound access, too restrictive, it would block legitimate internal traffic needed for Foundry services. Question 16. A team develops multiple AI applications in Microsoft Foundry that rely on shared prompt templates. The team requires a centralized way to track, version, and reuse prompt content across projects. You need to recommend a solution to track and reuse prompt content. Which approach should you recommend? A. Store prompts as versioned files in a Git repository. B. Register prompts as datasets in the Azure Machine Learning workspace. C. Embed prompts directly in application configuration files. D. Persist prompts in Azure Blob Storage with folder-level organization. Correct answer is A. Store prompts as versioned files in a Git repository. Here's why. Git repository A. provides centralized tracking, version control, and reuse across multiple projects, exactly what the team needs. Datasets B. intended for training, evaluation data, not prompt templates. Configuration files C. embedding prompts here makes them hard to reuse and version across projects. Blob storage D. good for storage, but lacks built-in version control and collaboration features. The best practice is to store prompts as versioned files in Git, ensuring consistency, traceability, and reusability across Foundry projects. Question 17. A team plans to deploy a large foundation model in Microsoft Foundry as part of a new enterprise AI capability. Different business units across the team's organization will access the model from various internal applications. You need to deploy a foundation model by minimizing latency. Which deployment type should you use? A. Developer. B. Data Zone Batch. C. Data Zone Standard. D. Global Batch. Correct answer is C. Data Zone Standard. Here's why. Data Zone Standard, C. designed for low latency inference, making it the right choice when multiple business units need fast responses from a shared foundation model. Developer, A. intended for experimentation and testing, not optimized for production latency. Data Zone Batch, B. optimized for large-scale batch processing, not real-time low-latency workloads. Global Batch, D. similar to batch, focused on throughput rather than minimizing latency. For enterprise AI applications requiring fast, interactive responses, the correct deployment type is Data Zone Standard. Question 18. A company's platform engineers manage the resource settings and governance of Microsoft Foundry. Developers must be able to create and update project assets but must not be able to change resource-level configurations. You need to enforce least privilege access for the engineers and developers. Which two actions should you perform? Each correct answer presents part of the solution. Choose two. Note: each correct selection is worth 1 point. A. Assign a resource-level Azure AI Administrator role to the platform engineers. B. Disable Microsoft Entra ID authentication for the Microsoft Foundry resource. C. Assign the Azure AI Developer role to the developers. D. Share a single API key across all teams. Correct answers are A. Assign a resource-level Azure AI Administrator role to the platform engineers. C. Assign the Azure AI Developer role to the developers. Here's why. Azure AI Administrator, A. grants platform engineers the ability to manage resource-level settings and governance. Azure AI Developer, C. grants developers permissions to create and update project assets, without allowing them to alter resource-level configurations. B. Disable Entra ID authentication, would weaken security, not enforce least privilege. D. Share API key, violates least privilege and security best practices. The correct approach is to assign administrator role at the resource level to engineers and developer role to developers, ensuring least privilege access. Question 19. You have a Microsoft Foundry project. You plan to use the Microsoft Foundry portal to fine-tune a base Azure OpenAI service model that can accept both text and images as input. You need to choose the suitable model. Which model should you choose? A. DaVinci 002. B. GPT-4o. C. GPT-35 Turbo. D. GPT-4. Correct answer is B. GPT-4o. Here's why. GPT-4o supports multimodal inputs, text plus images, and is explicitly listed in Microsoft Foundry documentation as fine-tunable for vision tasks. It is optimized for enterprise workloads requiring multimodal capabilities. DaVinci 002, legacy text-only model, not multimodal. GPT-35 Turbo, text-only, lower latency but no image input support. GPT-4, advanced text model, but the standard variant does not support multimodal fine-tuning in Foundry. Question 20. Note: this question is part of a series of questions that present the same scenario. Each question in the series contains a unique solution that might meet the stated goals. Some question sets might have more than one correct solution, while others might not have a correct solution. After you answer a question in this section, you will not be able to return to it. As a result, these questions will not appear on the review screen. You work in Microsoft Foundry with a prompt flow. You must manually evaluate prompts and compare results across prompt variants. You need to capture the inputs, outputs, token usage, and latencies for each flow run for the evaluation. Solution: create prompt variants and compare their outputs in the evaluation experience. Does the solution meet the goal? A. Yes. B. No. Correct answer is A. Yes. Here's why. The evaluation experience in Microsoft Foundry prompt flow is designed to let you run prompt variants and capture inputs, outputs, token usage, and latencies. By creating prompt variants and comparing them in evaluation, you meet the requirement to manually evaluate and compare prompts with full run metrics. Question 21. Note: this question is part of a series of questions that present the same scenario. Each question in the series contains a unique solution that might meet the stated goals. Some question sets might have more than one correct solution, while others might not have a correct solution. After you answer a question in this section, you will not be able to return to it. As a result, these questions will not appear on the review screen. You work in Microsoft Foundry with a prompt flow. You must manually evaluate prompts and compare results across prompt variants. You need to capture the inputs, outputs, token usage, and latencies for each flow run for the evaluation. Solution: use the Prompt Flow SDK to enable tracing for the flow before executing runs. Then run the flow to generate traceable results. Does the solution meet the goal? A. Yes. B. No. Correct answer is A. Yes. Here's why. The Prompt Flow SDK tracing feature allows you to capture detailed run metrics such as inputs, outputs, token usage, and latencies. By enabling tracing before executing runs, you generate traceable results that can be reviewed and compared across prompt variants. This matches the requirement for manual evaluation with full run metrics. Question 22. Note: this question is part of a series of questions that present the same scenario. Each question in the series contains a unique solution that might meet the stated goals. Some question sets might have more than one correct solution, while others might not have a correct solution. After you answer a question in this section, you will not be able to return to it. As a result, these questions will not appear on the review screen. You manage an Azure Machine Learning workspace. The Python script named script.py reads an argument named training_data. The training_data argument specifies the path to the training data in a file named dataset1.csv. You plan to run the script.py Python script as a command job that trains a machine learning model. You need to provide the command to pass the path for the dataset as a parameter value when you submit the script as a training job. Solution: Python train.py training_data. Does the solution meet the goal? A. Yes. B. No. Correct answer is B. Number. The solution provided, Python train.py training_data, does not meet the goal. The correct approach in Azure Machine Learning is to run the actual script, script.py, and pass the dataset path argument properly, not just the literal string training_data. Question 23. Note: this question is part of a series of questions that present the same scenario. Each question in the series contains a unique solution that might meet the stated goals. Some question sets might have more than one correct solution, while others might not have a correct solution. After you answer a question in this section, you will not be able to return to it. As a result, these questions will not appear on the review screen. You work in Microsoft Foundry with a prompt flow. You must manually evaluate prompts and compare results across prompt variants. You need to capture the inputs, outputs, token usage, and latencies for each flow run for the evaluation. Solution: in Microsoft Foundry, turn on tracing for the prompt flow of the project and execute test runs to produce trace data. Does the solution meet the goal? A. Yes. B. No. Correct answer is A. Yes. Enabling tracing in Foundry does indeed capture inputs, outputs, token usage, and latencies, so the solution correctly meets the goal. Question 24. Note: this question is part of a series of questions that present the same scenario. Each question in the series contains a unique solution that might meet the stated goals. Some question sets might have more than one correct solution, while others might not have a correct solution. After you answer a question in this section, you will not be able to return to it. As a result, these questions will not appear on the review screen. You manage an Azure Machine Learning workspace. The Python script named script.py reads an argument named training_data. The training_data argument specifies the path to the training data in a file named dataset1.csv. You plan to run the script.py Python script as a command job that trains a machine learning model. You need to provide the command to pass the path for the dataset as a parameter value when you submit the script as a training job. Solution: Python train.py training_data. Does the solution meet the goal? A. Yes. B. No. Correct answer is B. No. Here's why. The solution fails because it runs the wrong script, train.py instead of script.py, and passes the literal string training_data instead of the actual dataset path, dataset1.csv. Question 25. Hotspot. A company is creating an internal tool that summarizes long meeting transcripts and extracts action items. The model must process text inputs up to 200K tokens long, generate concise summaries in seconds, support interactive testing before integration into the app. You need to select, deploy, and test a model that supports summarization with low latency. How should you complete the configuration plan? Note: each correct selection is worth 1 point. Deploying and testing models for summarization. Requirement 1. Select a model. Option 1. Whisper. This is a speech-to-text model, not designed for summarization. Option 2. Phi-3 Mini. It supports up to 128K tokens, which is below the 200K requirement. Option 3. GPT 4.1 Mini. This supports very large context windows, meeting the 200K token requirement, and is capable of summarization. Option 4. Text Embedding ADA002. This is an embedding model, not a summarization model. The correct option is GPT 4.1 Mini. Requirement 2. Select a deployment type. Option 1. Batch endpoint. Optimized for throughput, but not suitable for low latency responses in seconds. Option 2. Custom container. Adds unnecessary complexity, not needed here. Option 3. Serverless endpoint. Provides low latency and scalability, but is best for lightweight workloads. Option 4. Managed real-time, also called Online Endpoint. This is best for interactive, low latency summarization tasks. The correct option is Managed Real-Time Endpoint. Requirement 3. Test the model. Option 1. Prompt flow. Useful for workflow orchestration, but not for quick interactive testing. Option 2. Microsoft Foundry Chat Playground. This is ideal for interactive testing before integration. Option 3. Microsoft Foundry Model Comparison. Used for benchmarking, not for playground testing. The correct option is Microsoft Foundry Chat Playground. So the completed configuration plan is: model, GPT 4.1 Mini. Deployment type, Managed Real-Time Endpoint. Testing, Microsoft Foundry Chat Playground. Question 26. Drag and drop. An organization uses Microsoft Foundry to develop generative AI projects that access shared Azure resources such as storage accounts and vector databases. The organization's security policy requires eliminating secret key-based authentication and enforcing least privilege access. You must configure identity and access so that services authenticate without stored credentials. Permissions are scoped appropriately across projects and shared resources. You need to configure the appropriate identity or access mechanism for each requirement. To answer, move the appropriate configuration mechanisms to the correct requirements. You may use each configuration mechanism once, more than once, or not at all. You may need to move the split bar between panes or scroll to view content. Note: each correct selection is worth 1 point. Configuration mechanisms. API key. Managed identity. Role-based access control role assignment. Service principal. Configure identity and access in Microsoft Foundry. Requirement 1. Allow Microsoft Foundry workloads to access Azure resources with keyless authentication. Requirement 2. Control which users can manage projects and deployments. Correct configuration. Requirement 1 should use managed identity. Requirement 2 should use role-based access control role assignment. Question 27. Drag and drop. A company plans to deploy a foundation model in Microsoft Foundry. The model must support the following workloads: a customer support workload used across multiple regions, a marketing workload that must remain within a specific region due to data residency requirements. You need to select the deployment type. Which deployment type should you use for each workload? To answer, move the appropriate deployment types to the correct requirements. You may use each deployment type once, more than once, or not at all. Note: each correct selection is worth 1 point. Deployment types: Standard, Global Standard, Data Zone Standard, Data Zone Batch. Workload deployment types: Customer Support, Marketing. Correct configuration. Customer support workload should use Global Standard because it is designed for use across multiple regions. Marketing workload should use Data Zone Standard because it ensures data residency within a specific region. Question 28. Drag and drop. A team manages prompts that are used by a generative AI application built on Microsoft Foundry. Multiple developers contribute prompt updates, and changes must be reviewed and tracked over time. The team requires that prompt changes are reviewed before being applied to the version in production. Previous prompt versions can be restored if issues occur. Prompt updates follow the same governance practices as the application code. You need to implement a controlled process for managing and updating prompts in production. How should you manage prompt updates to meet the requirements? To answer, move the appropriate actions to the correct requirements. You may use each action once, more than once, or not at all. Note: each correct selection is worth 1 point. Actions. Store prompts in a Git repository. Use gated pull requests for prompt changes. Use a prior agent version. Update prompts directly in production. Manage prompt updates. Requirement 1. Track changes and maintain history. Requirement 2. Review updates before production use. Requirement 3. Roll back to a specific prompt version. Correct configuration. Requirement 1 should use store prompts in a Git repository. Requirement 2 should use gated pull requests for prompt changes. Requirement 3 should use a prior agent version. Question 29. You manage a retrieval augmented generation system that uses Azure AI Search to retrieve documents from an indexed knowledge base. The system must support the following retrieval requirements. First, queries that include exact policy identifiers must return matching documents even when keywords are not an exact match. Second, natural language questions must prioritize semantically relevant documents even when keywords are not an exact match. You need to configure the retrieval approach to meet the requirements. How should you configure the retrieval behavior for each requirement? To answer, select the appropriate options in the answer area. Note: each correct selection is worth 1 point. Hybrid retrieval configuration. Retrieval requirement 1. Exact identifier matching. Options are: semantic ranking only, keyword-based retrieval disabled, vector similarity without keyword scoring, keyword-based retrieval with lexical scoring. Retrieval requirement 2. Natural language relevance. Options are: exact match filtering only, keyword-only search without embeddings, keyword-based retrieval with lexical scoring, semantic ranking over vector search results. Correct configuration. For exact identifier matching, use keyword-based retrieval with lexical scoring. For natural language relevance, use semantic ranking over vector search results. Question 30. You are reviewing a dataset that will be used for an advanced fine-tuning job in Microsoft Foundry. The fine-tuning job uses preference comparison data. You review the following dataset excerpt. Training record 1. Input. You are a policy assistant. User says, summarize policy X for managers. Preferred output. Policy X applies to all managers and outlines approval requirements. Non-preferred output. Policy X applies to all managers and outlines approval requirements. Training record 2. Input. You are a policy assistant. User says, what is the retention period? Preferred output. The retention period is 7 years. Non-preferred output. The retention period is 5 years. For each of the following statements, select yes if the statement is true. Otherwise, select number. Note: each correct selection is worth 1 point. Preference-based fine-tuning dataset validation. Statement 1. The first record provides a usable preference signal for preference-based fine-tuning. Options: yes or no. Statement 2. The second record provides a usable preference signal for preference-based fine-tuning. Options: yes or no. Statement 3. Each preferred and non-preferred output in the dataset contains a valid assistant message as required for direct preference optimization. Options: yes or no. Statement 4. Both records must contain different preferred and non-preferred outputs to produce usable training signals. Options: yes or no. Correct answers are: Statement 1. The first record provides a usable preference signal for preference-based fine-tuning. Correct answer: no. Statement 2. The second record provides a usable preference signal for preference-based fine-tuning. Correct answer: yes. Statement 3. Each preferred and non-preferred output in the dataset contains a valid assistant message as required for direct preference optimization. Correct answer: yes. Statement 4. Both records must contain different preferred and non-preferred outputs to produce usable training signals. Correct answer: yes. Question 31. You manage a retrieval augmented generation system that retrieves internal policy documents from a vector index. Recent analysis shows that retrieved results frequently include duplicated content from the same document, and retrieved chunks sometimes span unrelated policy sections. You review the following retrieval and ingestion configurations. Configuration 1. Chunk size: 1200. Chunk overlap: 400. Similarity threshold: 0.80. Retrieval strategy: vector, top K, 8. Configuration 2. Chunk size: 300. Chunk overlap: 40. Similarity threshold: 0.90. Retrieval strategy: vector, top K, 8. You need to reduce duplicated retrieval results and improve chunk relevance across policy sections. For each of the following statements, select yes if the statement is true. Otherwise, select number. Note: each correct selection is worth 1 point. Statement 1. Configuration 1 produces duplicated content across retrieved chunks. Options: yes or no. Statement 2. Configuration 2 enforces stricter similarity filtering that can exclude relevant chunks. Options: yes or no. Statement 3. Lowering the similarity threshold is required to reduce semantic dilution. Options: yes or no. Statement 4. Switching to keyword-only search will eliminate semantic dilution while preserving semantic relevance. Options: yes or no. Correct answers are: Configuration 1 produces duplicated content across retrieved chunks, right pointing arrow yes. Configuration 2 enforces stricter similarity filtering that can exclude relevant chunks, right pointing arrow yes. Lowering the similarity threshold is required to reduce semantic dilution, right pointing arrow no. Switching to keyword-only search will eliminate semantic dilution while preserving semantic relevance, right pointing arrow no. Question 32. A team is building a generative AI agent by using retrieval augmented generation in Microsoft Foundry. The team frequently updates prompt content. The team must be able to track changes across contributors while avoiding full application redeployments. You need to enable rapid prompt iteration with traceability. Applications consuming the agent must be able to use updated prompts without requiring redeployment. What should you configure for each requirement? To answer, select the appropriate options in the answer area. Note: each correct selection is worth 1 point. Prompt management configuration. Requirement 1. Track prompt changes across teams. Options: Git repository, CD pipeline, environment variables, agent's latest published version reference, Azure Blob Storage, Azure Machine Learning data stores. Requirement 2. Apply prompt updates without redeployment. Options: Git repository, CD pipeline, environment variables, agent's latest published version reference, Azure Blob Storage, Azure Machine Learning data stores. Correct answers are: track prompt changes across teams, right pointing arrow Git repository. Apply prompt updates without redeployment, right pointing arrow agent's latest published version reference. Question 33. A data science group at a healthcare firm is moving their local Jupyter Notebook development environment to a cloud-based architecture. To ensure all team members can access managed data, environments, and tracking capabilities from a single entry point, what should be the initial step in their Azure configuration? A. Register all existing local datasets as Azure Machine Learning assets. B. Provision a centralized Azure Machine Learning workspace. C. Set up a managed online endpoint for model testing. D. Launch a new project within Microsoft Foundry. Correct answer is B. Provision a centralized Azure Machine Learning workspace. Here's why. The Azure Machine Learning workspace acts as the foundational resource in Azure ML. It provides a single entry point for managing datasets, experiments, environments, models, and tracking capabilities across the team. Without this workspace, other steps like registering datasets or deploying endpoints cannot be properly centralized or managed. Question 34. A company needs to deploy a churn prediction model that uses the MLflow format. This model must support two distinct scenarios, one requiring immediate, low-latency responses for live user interactions, and another for processing massive scheduled files containing millions of data rows. Which deployment combination satisfies these needs? A. Use a batch endpoint for live interactions and a real-time endpoint for scheduled files. B. Use a job-based pipeline for live interactions and a managed compute cluster for scheduled files. C. Use a real-time endpoint for live interactions and a batch endpoint for scheduled files. D. Use a registered model artifact for live interactions and an online endpoint for scheduled files. Correct answer is C. Use a real-time endpoint for live interactions and a batch endpoint for scheduled files. Here's why. Real-time endpoint. Designed for low latency, immediate responses, perfect for live user interactions. Batch endpoint. Optimized for large-scale, scheduled processing of millions of rows, ideal for file-based workloads. Question 35. You are preparing a custom training dataset for a multi-turn chat scenario within the Azure OpenAI service. To ensure the fine-tuning process functions correctly, which specific file format and text encoding are required? A. A CSV file encoded in UTF-16B, a JSONL file encoded in UTF-8, CATSV file encoded in ASCII, a standard JSON file encoded in ISO 88591. Correct answer. B. A JSONL file encoded in UTF-8. Here's why. JSONL format. Required for fine-tuning because each line represents a separate training example, making it efficient for large datasets. UTF-8 encoding ensures compatibility across systems and avoids issues with special characters in training data. Question 36. An organization operates separate Azure Machine Learning workspaces for their testing and production phases. They want to utilize the same set of validated environment assets across both workspaces without manually recreating them or duplicating the underlying data. What is the most efficient way to share these assets? A. Synchronize assets using a workspace-level Git integration. B. Export the assets to local storage and re-upload them to production. C. Distribute the assets via an Azure Machine Learning registry. D. Attach the asset to a shared pipeline component. Correct answer. C. Distribute the assets via an Azure Machine Learning registry. Here's why. In Microsoft Azure Machine Learning, a registry is specifically designed to share and manage assets such as environments, models, components, data assets across multiple workspaces and even across subscriptions, with appropriate permissions. A registry provides a centralized location where validated assets can be versioned and reused without copying or recreating them in each workspace. Question 37. A team has deployed a classification model to a managed online endpoint in Azure Machine Learning. They need to update the model to a newer version but must ensure that the transition does not negatively impact the current user experience. Which risk reduction strategy should they employ? A. Completely replace the existing endpoint with the new model version immediately. B. Deploy the new version to a batch endpoint for validation first. C. Implement traffic splitting to gradually route a percentage of users to the new deployment. D. Redirect all incoming production traffic to the new version and monitor for errors. Correct answer. C. Implement traffic splitting to gradually route a percentage of users to the new deployment. Here's why. Traffic splitting. Safest way to roll out new versions. It allows gradual exposure of users to the updated model, minimizing risk and enabling monitoring before full adoption. Question 38. You are configuring a Microsoft Foundry environment to support several different development teams. Each team needs its own isolated workspace to prevent resource contention, but the organization still requires centralized management of security policies and shared data connections. Which configuration satisfies both requirements? A. Assign every team to a single shared Microsoft Foundry project. B. Create a unique Microsoft Foundry project for each team under a shared resource. C. Provision a separate Microsoft Foundry resource for every individual team. D. Deploy all teams into a single Azure subscription without resource boundaries. Correct answer is B. Create a unique Microsoft Foundry project for each team under a shared resource. Here's why. Unique Foundry projects' right-pointing arrow provide isolation for each team's workspace, preventing resource contention. Shared resource right-pointing arrow ensures centralized governance, security policy enforcement, and shared data connections across all projects. Question 39. A financial services company is concerned about data residency and latency for their generative AI workloads. They have a customer support tool that must be accessible across multiple global regions and a marketing tool that is legally required to process data within a single specific region. Which deployment types should be used for these workloads? A. Global Standard for Customer Support and Data Zone Standard for Marketing. B. Standard for Customer Support and Global Batch for Marketing. C. Data Zone Standard for Customer Support and Global Standard for Marketing. D. Data Zone Batch for Customer Support and Standard for Marketing. Correct answer is A. Global Standard for Customer Support and Data Zone Standard for Marketing. Here's why. Global Standard deployment ensures low latency access across multiple regions, ideal for customer support tools that must serve users worldwide. Data Zone Standard deployment restricts processing to a single region, satisfying legal and compliance requirements for data residency, which is critical for the marketing tool. Question 40. After deploying a machine learning model to production, a team notices that the accuracy of predictions is beginning to decline over time. They suspect that the distribution of incoming data has shifted compared to the training set. What monitoring configuration should they enable to address this issue? A. Increase the compute size of the inference cluster. B. Enable data drift monitoring and configure automated alerts. C. Manually retrain the model on the most recent week of data. D. Re-register the model in the workspace with new metadata. Correct answer is B. Enable data drift monitoring and configure automated alerts. Here's why. Data drift monitoring detects when the statistical properties of incoming data diverge from the training dataset. This is the most direct way to identify why accuracy is declining and to trigger retraining or investigation. Question 41. You are building a generative AI assistant and need to evaluate the quality of the language produced by different prompt variants. Specifically, you want to ensure the generated responses are grammatically correct and read naturally. Which built-in evaluator in Microsoft Foundry should you use? A. Groundedness. B. Coherence. C. Fluency. D. Similarity. Correct answer is C. Fluency. Here's why. Fluency measures grammatical correctness and naturalness of generated text, making it the right evaluator for assessing language quality. A. Groundedness evaluates factual accuracy of responses against source material, not grammar or naturalness. B. Coherence focuses on logical flow and consistency of ideas, not sentence-level grammar. D. Similarity compares generated output to reference text, useful for alignment but not for evaluating natural language fluency. Question 42. A data science team is using MLflow to track multiple experiments. They have identified a high-performing model and now need to ensure it can be versioned and deployed across different environments. What is the correct sequence of actions to take? A. Export model files to a local drive and re-upload them to production. B. Capture model artifacts from the training run and register them in the workspace. C. Tag the training experiment and create a manual deployment script. D. Archive the training dataset and publish the model to a public registry. Correct answer is B. Capture model artifacts from the training run and register them in the workspace. Here's why. Model artifacts. These are the files, weights, configurations, dependencies produced during training. Capturing them ensures reproducibility. Registering the model places the model in a central workspace registry, enabling versioning, deployment, and lifecycle management across environments. Question 43. A team manages an Azure Machine Learning workspace where they deploy models to online endpoints. The team needs to introduce a new version of a model to production without disrupting existing users. The team must validate the new version before full rollout. You need to reduce risk during deployment. A. Deploy the model to a batch endpoint. B. Split traffic between deployments. C. Replace the existing endpoint. D. Route all traffic to the new deployment. Correct answer is B. Split traffic between deployments. Here's why. Traffic splitting allows gradual rollout of a new model version by directing a percentage of traffic to it while the rest continues using the stable version. This reduces risk and enables validation under real-world conditions. Question 44. You have a deployment of an Azure OpenAI service-based model. You plan to fine-tune the model. You need to prepare a file that contains training data. Which file format should you use? A. CSV BTSVC JSONLD JSON. Correct answer is C. JSONL. Here's why. JSONL format. Required for fine-tuning in Azure OpenAI service. Each line represents a separate training example, making it efficient for large datasets and multi-turn conversations. A. CSV. Useful for tabular data but not supported for fine-tuning models. B. TSV. Same limitation as CSV, not compatible with fine-tuning requirements. D. JSON. Standard JSON can store structured data, but fine-tuning specifically requires JSONL, line-delimited JSON. Question 45. You have a deployment of an Azure OpenAI service-based model. You plan to fine-tune the model. You need to prepare a file that contains training data for multi-turn chat. Which file encoding method should you use? A. ISO 8859-1 BUTF-16 circa UTF-8D ASCII. Correct answer is C. UTF-8. Here's why. UTF-8 encoding. Required for Azure OpenAI fine-tuning because it supports multilingual text, special characters, and ensures compatibility across systems. A. ISO 88591. Limited character set, unsuitable for diverse training data. B. UTF-16. Not supported by Azure OpenAI fine-tuning, may cause compatibility issues. D. ASCII. Too restrictive, cannot handle non-English or special characters. Question 46. You are fine-tuning a base language model to analyze customer feedback. You label examples of support tickets. You must improve classification accuracy by configuring and fine-tuning the base model in Microsoft Foundry. You need to configure and run fine-tuning. What should you do first? A. Use MLflow to generate multiple prompt templates for evaluation. B. Deploy the base model to an online endpoint before starting fine-tuning. C. Enable tracing for all inference calls in the evaluation pipeline. D. Format the dataset as a JSONL file with prompt completion pairs and upload the file. Correct answer is D. Format the dataset as a JSONL file with prompt completion pairs and upload the file. Here's why. JSONL with prompt completion pairs right pointing arrow. This is the required format for fine-tuning in Microsoft Foundry and Azure OpenAI. Each line represents a training example, pairing the input, prompt, with the desired output, completion. Question 47. A team is working in Microsoft Foundry to test and compare large language model, LLM, prompt variants in a development environment. The team requires consistent inputs to evaluate prompt variants without relying on live user traffic. You need to create a controlled evaluation of input data. Which action should you perform first? A. Generate synthetic interaction data. B. Configure content filters. C. Apply a block list. D. Enable observability metrics. Correct answer is A. Generate synthetic interaction data. Here's why. Synthetic interaction data provides controlled, repeatable inputs for evaluating prompt variants. This ensures fairness and consistency in testing without depending on unpredictable live traffic. Question 48. An organization maintains separate Azure Machine Learning workspaces for development and production. Both environments must use the same validated assets without duplicating them. Assets must be shared across workspaces while maintaining centralized governance and version control. You need to enable reuse of assets across workspaces without copying them. A. Enable workspace-level Git integration and sync assets between repositories. B. Publish the asset as a pipeline component. C. Create a shared Azure Machine Learning environment that includes the asset. D. Publish the asset to an Azure Machine Learning registry. Correct answer is D. Publish the asset to an Azure Machine Learning registry. Here's why. Azure ML Registry. Designed to share and reuse assets, datasets, environments, models, components, across multiple workspaces. It ensures centralized governance, version control, and avoids duplication. Question 49. An Azure Machine Learning workspace processes sensitive training data. The workspace must not be accessible from the public internet. You need to restrict network access. A. Azure Firewall Rules. B. Private endpoints. C. Network security groups. D. Service endpoints. Correct answer is B. Private endpoints. Here's why. Private endpoints provide secure connectivity to Azure services over a private IP address within your virtual network. This ensures the workspace is isolated from the public internet, meeting compliance and security requirements. Question 50. A team is experimenting with traditional models for a classification workflow in Azure Machine Learning. The team requires a consistent way to manage assets that are created during experimentation. You need to ensure that artifacts can be reused and governed across projects. Which asset should you register? A. Model. B. Component. C. Environment. D. Pipeline. Correct answer is A. Model. Registering a model in the Azure ML Model Registry ensures version tracking, lineage, governance, and reusability across projects. This is the recommended way to manage artifacts created during experimentation. Question 51. You manage a Microsoft Foundry project. You build a multi-turn chatbot application. You plan to filter your traces to identify issues while observing how the application is responding. The solution must not use an external knowledge base. You need to select an evaluation metric. Which built-in evaluator should you use? A. Relevance evaluator. B. Similarity evaluator. C. QA evaluator. D. Coherence evaluator. Correct answer is D. Coherence evaluator. Here's why. Coherence evaluator measures how logically consistent and natural the chatbot's multi-turn responses are. It's the right choice when you want to analyze traces without relying on an external knowledge base. Question 52. A team deploys a model to a real-time endpoint in Azure Machine Learning. You deploy some updates to the endpoint. The endpoint returns errors after the new deployment is released. You need to restore the service as quickly as possible. A. Roll back traffic to the previous deployment. B. Delete the endpoint and immediately redeploy it. C. Change the authentication type to Azure Machine Learning token-based authentication. D. Increase the compute size. Correct answer is A. Roll back traffic to the previous deployment. Here's why. Rollback traffic. Azure ML Online Endpoints support multiple deployments. If a new deployment fails, you can quickly redirect traffic back to the stable previous deployment, restoring service with minimal downtime. Question 53. A team is developing a generative AI assistant. The team is experimenting with multiple prompt variants to improve the user experience. When comparing prompt variants, the team plans to assess whether the generated responses are grammatically correct. You need to evaluate the quality of the language from the generated responses. Which evaluator should you use? A. Coherence. B. Textual similarity. C. Groundedness. D. Fluency. Correct answer is D. Fluency. Here's why. Fluency evaluator measures grammatical correctness and naturalness of generated text, making it the right choice for evaluating language quality. Question 54. A data science team trains a classification model that predicts loan approval outcomes. Before registering the model, the team must ensure the following: predictions must not disproportionately impact protected groups. Prediction errors can be evaluated across different data segments. You need to assess whether the model meets responsible AI expectations. Which two approaches should you use? Each correct answer presents part of the solution. Choose two. A. Analyze error rates across defined demographic cohorts. B. Evaluate feature importance for prediction transparency. C. Measure endpoint latency under load. D. Analyze error rates across the global cohort. E. Validate inference schema compatibility. Correct answers are A and B. Analyze error rates across defined demographic cohorts. Ensures fairness by checking whether error rates disproportionately affect protected groups. Evaluate feature importance for prediction transparency. Provides interpretability and transparency, aligning with responsible AI principles. Question 55. A team schedules weekly retraining of a model using Azure ML pipelines. They also want retraining triggered automatically when production data significantly deviates from training data distribution, without duplicating pipeline logic. What should they implement? A. One pipeline triggered by schedule and data drift alerts. B. Azure function to retrain model manually. C. Notebook-based retraining process. D. Two independent pipelines with shared scripts. Correct answer is A. One pipeline triggered by schedule and data drift alerts. Here's why. Data drift monitoring can trigger retraining automatically when production data diverges from training distribution. Combining scheduled retraining with data drift alerts avoids duplication and ensures governance. Question 56. A company requires that only models meeting predefined performance thresholds are registered and deployed. The solution must be fully automated within the ML workflow. What should you implement? A. GitHub pull request checks. B. Conditional logic in pipeline. C. Azure monitor alerts. D. Manual approval gate. Correct answer is B. Conditional logic in pipeline. Here's why. Use conditional steps in Azure ML pipelines to enforce performance thresholds. This ensures models are only registered, deployed if evaluation metrics meet predefined criteria, fully automated within the workflow. Question 57. A team iterates prompts used by a generative AI agent. The team must support internal review before releasing changes. The team must track prompt changes with a clear history for audit and rollback. Compare prompt variants in parallel without affecting the prompt used in the production environment. You need to select the appropriate source control approach for each requirement. To answer, drag the appropriate source controls to the correct requirements. Source controls. 1. Git repository. 2. Azure Machine Learning notebooks. 3. Azure Storage. 4. Branch-based workflow. Requirements. Track prompt changes. Evaluate prompt variants. Correct answers are Git repository. Provides version history, audit trail, and rollback capability. Branch-based workflow. Enables parallel experimentation without impacting production prompts. Question 58. During training, pipelines occasionally fail due to schema mismatch caused by upstream data changes. You need a robust and automated solution that prevents invalid data from reaching training steps. What is the best approach? A. Ignore schema differences. B. Retrain manually when failure occurs. C. Add a data validation component in pipeline. D. Use larger compute. Correct answer is C. Add a data validation component in pipeline. Here's why. Data validation ensures schema consistency and prevents invalid data from breaking training workflows. This is the recommended automated safeguard in Azure ML pipelines. Question 59. A team maintains infrastructure as code, IAC, templates to provision Azure Machine Learning resources. Provisioning must be triggered by changes in the templates and executed without manual intervention. You need to automate resource provisioning. Which action should you take for each requirement? To answer, drag the appropriate actions to the correct requirements. Actions. 1. Use an Azure Service Principal. 2. Create a manual deployment script. 3. Configure a GitHub Actions workflow. 4. Run Azure CLI commands from a local machine. Requirement. Trigger provisioning on repository changes. Authenticate securely during workflow execution. Correct answers are: configure a GitHub Actions workflow. Automates provisioning when IAC templates change in the repository. Use an Azure Service Principal. Provides secure, non-interactive authentication for C/CD workflows. Question 60. A team deploys a generative AI application that uses a model deployed in Microsoft Foundry. The application must support latency monitoring under production load. You need to enable performance observability. Which 3 actions should you perform in sequence? To answer, move the appropriate actions from the list of actions to the answer area and arrange them in the correct order. Actions list. Set up the model endpoint in Foundry. Enable logging. Apply a term block list. Generate token embeddings. Configure monitoring metrics. The correct sequence. 1. Set up the model endpoint in Foundry. Establishes the deployed endpoint for production traffic. 2. Enable logging. Captures latency and performance data. 3. Configure monitoring metrics. Provides observability dashboards and alerts under load. Question 61. An organization operates a generative AI application in production by using Microsoft Foundry. The application serves live user traffic and is updated by a data scientist team regularly as prompts and models evolve. The application intermittently times out during production use, which requires ongoing visibility into runtime behavior. The team must also validate model quality and safety before releasing new updates to avoid introducing regressions. You need to apply the correct mechanisms for continuous runtime monitoring and for release time validation. Which mechanisms should you use for each requirement? To answer, drag the appropriate mechanisms to the correct requirements. Mechanisms: diagnostic logs, evaluation workflow, block list update, observability metrics. Requirements: runtime monitoring, release validation. Correct answers: observability metrics. Provides visibility into latency, throughput, and error rates during production use. Evaluation workflow ensures model quality and safety checks before updates are released, preventing regressions. Question 62. A machine learning model is deployed to production in Azure Machine Learning and is actively serving predictions for a business application. The model was trained by using a historical dataset that represented expected input patterns at the time of deployment. The team working on the model must ensure the following: changes in input data distribution are detected. Appropriate actions are triggered when predefined thresholds are exceeded. You need to configure monitoring to meet the requirements. Which configuration should you use for each requirement? To answer, select the appropriate options in the answer area. Requirement 1. Detect changes in input data distribution. Options: enable data drift monitoring. Increase compute size. Retrain the model manually. Requirement 2. Trigger action when thresholds are exceeded. Options: configure alerts. Delete the endpoint. Re-register the model. Correct answers are: enable data drift monitoring. Detects changes in input data distribution compared to training data. Configure alerts. Automatically triggers actions when thresholds are exceeded. Question 63. Case study. Problem statement. Fabricam Inc. must design and implement an Azure-based AI operations solution that enables reliable training, evaluation, deployment, and iteration of generative AI models. The solution must support experimentation and gradual rollout while ensuring governance, security, and operational stability. The data science and platform teams must collaborate to deliver this solution by using Azure Machine Learning and Microsoft Foundry capabilities. You need to recommend an experiment tracking strategy that ensures consistent experiment results. What should you recommend? A. Azure Machine Learning Job Output Logs. B. MLflow Experiment Tracking. C. Application Insights Logs. D. Azure Monitor Alerts. Correct answer is B. MLflow Experiment Tracking. Because MLflow Experiment Tracking is designed to log parameters, metrics, and artifacts across runs, it ensures reproducibility and consistent experiment results. The other options, Job Logs, Application Insights, Azure Monitor, focus on monitoring or diagnostics, not structured experiment tracking. Question 64. You train a model in Azure Machine Learning. You plan to capture experiment details for later comparison. The training code must log parameters and metrics for each run. You review the following training script. This training script in short, it sets up a named experiment with MLflow.set_experiment, classification experiment. Inside MLflow, start_run, it trains a logistic regression model on the iris dataset. It logs a parameter, max_iter, and a metric, accuracy, using MLflow.log_param and MLflow.log_metric. Finally, it logs the trained model artifact with MLflow, sklearn.log_model. You need to verify whether the training script meets the experiment tracking requirement. For each of the following statements, select yes if the statement is true. Otherwise, select number. Note: each correct selection is worth 1 point. Statement: the code ensures that training parameters and metrics are tracked for each run. Options: yes, no. Statement: the code uses the experiment name to define the artifact path of the logged model. Options: yes, no. Statement: the code associates the run with a named experiment. Options: yes, no. Here's the evaluation of the script against the statements. Statement 1. The code ensures that training parameters and metrics are tracked for each run. Answer: yes. It uses MLflow.log_param and MLflow.log_metric inside MLflow. Start_run, so parameters and metrics are tracked. Statement 2. The code uses the experiment name to define the artifact path of the logged model. Answer: no. The experiment name is set with MLflow.set_experiment, but the artifact path for the model is defined explicitly as model in MLflow. sklearn.log_model. The experiment name does not define the artifact path. Statement 3. The code associates the run with a named experiment. Answer: yes. MLflow.set_experiment, classification experiment, ensures the run is linked to the named experiment. So the correct selections are yes, no, yes. Question 65. You deploy a model to production but do not have labeled data available for evaluating prediction accuracy. However, you must monitor model health continuously. What is the best strategy? A. Use data drift detection. B. Disable monitoring. C. Monitor accuracy metrics. D. Perform manual evaluation only. The best strategy is a use data drift detection. Here's why. When you don't have labeled data, you cannot directly monitor accuracy metrics. Data drift detection continuously compares current input data against the training dataset distribution to identify shifts that may impact model reliability. Disabling monitoring or relying only on manual evaluation would leave the model blind to changes. Accuracy metrics require labels, which are not available in this scenario. So the correct choice is data drift detection, as it allows continuous monitoring of model health without labeled data. Question 66. You need to run large-scale inference jobs on millions of records periodically. Jobs are not latency sensitive but must be cost-efficient and scalable. Which deployment option is most appropriate? A. Notebook execution. B. Managed online endpoint. C. Local endpoint. D. Batch endpoint. Correct answer is D. Batch endpoint. Designed for large-scale, periodic inference jobs. It is cost-efficient, scalable, and optimized for scenarios where latency is not critical. Perfect for millions of records processed in bulk. Question 67. A financial services company is deploying Microsoft Foundry to host generative AI workloads that process regulated customer data. The Microsoft Foundry environment must prevent any public network exposure while still allowing services managed by Microsoft Foundry to communicate with dependent Azure resources. Security auditors require that all traffic to and from the Microsoft Foundry resource remain on private networks, with no public endpoints available. You need to configure the Microsoft Foundry environment so that network access is restricted while maintaining full platform functionality. Which two actions should you perform? A. Disable all inbound network access. B. Deploy the Microsoft Foundry resource in a separate Azure subscription. C. Use API key authentication for all model endpoints. D. Disable public network access to the Microsoft Foundry resource. E. Configure a managed virtual network for the Microsoft Foundry resource. Correct answers are D. Disable public network access to the Microsoft Foundry resource. E. Configure a managed virtual network for the Microsoft Foundry resource. Disable public network access ensures that the Foundry resource cannot be reached from the public internet, meeting the requirement of no public endpoints. Configure managed virtual network provides secure, private connectivity between Foundry services and dependent Azure resources, while maintaining full platform functionality. Question 68. A team accidentally deploys an outdated model version due to incorrect tagging. You need to enforce strict deployment governance and version control. A. Rename models. B. Use version pinning and approval workflows. C. Increase logging. D. Store models locally. Correct answer is B. Use version pinning and approval workflows. Here's why. Version pinning and approval workflows ensures that only approved model versions can be deployed. Pinning locks deployments to specific versions, while approval workflows enforce governance by requiring validation before promotion to production. Question 69. A real-time endpoint experiences sporadic latency spikes. Investigation reveals instances scale down to 0 during inactivity. You need to reduce latency without significantly increasing cost. What should you configure? A. Increase timeout settings. B. Set minimum instance count. C. Switch to batch endpoint. D. Reduce logging. Correct answer is B. Set minimum instance count. Here's why. Minimum instance count prevents the endpoint from scaling down to 0, ensuring at least one instance is always warm and ready to handle requests. This reduces cold start latency spikes while keeping costs controlled, since you don't need to run many instances continuously. Question 70. You want to ensure ML pipelines produce identical results when executed in different regions or workspaces. Which factor is most critical to control for reproducibility? A. Same compute SKU. B. Same dataset name. C. Versioned datasets and environments. D. Same user identity. Correct answer is C. Versioned datasets and environments. Here's why. Versioned datasets and environments ensures reproducibility by locking both the input data and the execution environment, dependencies, libraries, OS settings. This guarantees identical results across different regions or workspaces. Question 71. Hotspot. You have an Azure subscription. You plan to build a solution that will analyze scanned documents and export relevant fields to a database. You need to recommend which Azure AI service to deploy for the following types of documents: internal expenditure request authorization forms, supplier invoices. The solution must minimize development effort. Answer area. Internal expenditure request authorization forms, an Azure AI document intelligence custom model, an Azure AI document intelligence pre-built model, Azure AI Custom Vision, Azure AI Immersive Reader, Azure AI Vision, Supplier Invoices, Azure AI Immersive Reader, an Azure AI Document Intelligence Custom Model, an Azure AI Document Intelligence Pre-Built Model, Azure AI Custom Vision, Azure AI Vision. Correct answers are Internal Expenditure Request Authorization Forms, Azure AI Document Intelligence Custom Model, Supplier Invoices, Azure AI Document Intelligence Pre-Built Model. Here's why. Internal forms are unique to the organization, so a custom model is required to train on those specific layouts and fields. Invoices are a common, standardized document type, so the pre-built invoice model minimizes development effort by leveraging Microsoft's ready-made solution. Question 72. Hotspot. A team manages an Azure Machine Learning workspace and deploys a model to an endpoint. A deployed online endpoint shows inconsistent response times during periods of high traffic. You need to identify potential performance degradation. Which 3 metrics should you monitor? Each correct answer presents part of the solution. Note: each correct selection is worth 1 point. A. Feature count. B. Requests per minute. C. Connections active. D. Dataset size. E. Request latency. Correct answers are B. Requests per minute. C. Connections active. E. Request latency. Here's why. Requests per minute helps track traffic load and detect spikes that may overwhelm the endpoint. Connections active indicates concurrent usage, which can cause bottlenecks if too many clients connect simultaneously. Request latency directly measures response time and highlights performance degradation. Question 73. You create an Azure Machine Learning workspace and install the MLflow library. You need to log different types of data by using the MLflow library. Which method should you use? To answer, select the appropriate options in the answer area. Note: each correct selection is worth 1 point. Answer area: matplotlib plot log underscore param log underscore metric log underscore text log underscore image log underscore figure boolean value log underscore param log underscore metric log underscore text log underscore image log underscore figure. Before answering, let's review all the available methods. Log underscore param, used to log parameters and configuration settings such as learning rate, batch size, number of epochs, or boolean values. Log underscore metric, used to log numeric performance metrics such as accuracy, precision, recall, F1 score, and RMSE. Log underscore text, used to log text strings or text files as artifacts. Log underscore image, used to log image files or image arrays. Log underscore figure, used to log visualization objects such as matplotlib and plotly figures. Now let's evaluate each item. Matplotlib plot. A matplotlib plot is a figure object. MLflow provides a dedicated method for logging figures. The correct answer is log underscore figure. Boolean value. A Boolean value such as true or false is a configuration setting. Examples include use underscore scaling equals true or normalize underscore data equals false. Configuration settings are logged as parameters. Question 74. You manage an Azure Machine Learning workspace. You create an experiment named Experiment 1 by using the Azure Machine Learning Python SDK v2 and MLflow. Consider the following code. Runs equals MLflow. Search underscore runs. Experiment underscore names equals experiment 1 inch. Max underscore results equals 5. Order underscore by equals start underscore time ASC. Runs. Status equals failed. For each of the following statements, select yes if the statement is true. Otherwise, select number. Statement 1. Aborted runs are returned. Statement 2. The latest 5 experiment runs are returned. Statement 3. The jobs that are returned have been cancelled or killed by the user or system. Statement 4. All metrics and their values are returned for the returned experiment runs. Correct answers. Statement 1. Aborted runs are returned. Let's analyze. The filter is runs, status equals failed. This returns only runs whose status is failed. Aborted runs have a different status, typically aborted. Therefore, aborted runs are not returned. Correct answer. No. Statement 2. The latest 5 experiment runs are returned. Let's analyze. The query specifies order underscore by equals start underscore time ASC. ASC means ascending order, which returns the earliest runs first. If we wanted the latest runs, we would use DESC. Therefore, the latest 5 runs are not returned. Correct answer. No. Statement 3. The jobs that are returned have been cancelled or killed by the user or system. Let's analyze. The filter returns only runs with status failed. Cancelled or killed jobs typically have statuses such as cancelled or aborted. Failed indicates the run ended because of an error or failure, not because it was cancelled. Therefore, the returned jobs are not cancelled or killed jobs. Correct answer. No. Statement 4. All metrics and their values are returned for the returned experiment runs. Let's analyze. The MLflow search underscore runs function returns run information including metrics, parameters, tags, and other metadata for the matching runs. Therefore, metrics and their values are included in the returned results. Correct answer: yes. Question 75. You create an Azure Machine Learning workspace. You must use the Python SDK v2 to implement an experiment from a Jupyter notebook in the workspace. The experiment must log string metrics. Which method should you use? To answer, move the appropriate method from the list of actions to the answer area. Actions: A MLflow.log_artifact, B MLflow.log_dict, C MLflow.log_metric, D MLflow.log_text. Correct answer is D MLflow.log_text. Here's why. MLflow.log_text is the correct method for logging string values such as messages, notes, or textual metrics. While MLflow.log_metric, right pointing arrow used for numeric values, accuracy, loss, etc. MLflow.log_artifact, right pointing arrow used for files or directories. MLflow.log_dict, right pointing arrow used for structured data, JSON, dicts. Question 76. You create an Azure Machine Learning workspace. You need to use the shared file system of the workspace to store a clone of a private Git repository. Which 4 actions should you perform in sequence? To answer, move the appropriate actions from the list of actions to the answer area and arrange them in the correct order. List of actions. Copy the private key to GitHub. Create a compute instance. Run the SSH keygen command. Copy the public key to GitHub. Run the git clone command. Correct sequential answer: 1. Create a compute instance. Step 1. You first need to create a compute instance to actively access and interact with the shared file system of your Azure Machine Learning workspace. 2. Run the SSH keygen command. Step 2. Run this command in the terminal of your compute instance to generate a new SSH key pair, a public and a private key, used for secure authentication. 3. Copy the public key to GitHub. Step 3. Take the generated public key, .pub, and add it to your GitHub account settings under SSH keys so GitHub can authenticate your compute instance's connection. 4. Run the git clone command. Step 4. Finally, use the git clone command via SSH to clone the private repository directly onto the shared workspace file system. Question 77. You need to implement source control for scripts in an Azure Machine Learning workspace. You use a terminal window in the Azure Machine Learning Notebook tab. You must authenticate your Git account with SSH. You need to generate a new SSH key. Which 4 actions should you perform in sequence? To answer, move the appropriate actions from the list of actions to the answer area and arrange them in the correct order. Actions. Copy the public key to GitHub. Run the SSH keygen command. Press enter to accept the default file location. Type a secure passphrase. Verify the default file location, /home/azurias or /.ssh. Correct sequential answer: 1. Run the SSH keygen command. Step 1. Execute this command in your Azure ML terminal window to kick off the key generation wizard. 2. Verify the default file location, /home/azurias or /.ssh. Step 2. When prompted by the terminal on where to save the newly created key pair, check that it defaults to your profile's hidden.ssh directory. 3. Press enter to accept the default file location. Step 3. Confirm the verified folder path by pressing enter so the system saves the public and private keys in the correct directory. 4. Type a secure passphrase. Step 4. Provide a strong passphrase when prompted to add an extra layer of password protection to your private key file. Question 78. You are implementing hyperparameter tuning for a model training from a notebook. The notebook is in an Azure Machine Learning workspace. You must configure a grid sampling method over the search space for the num_hidden_layers and batch_size hyperparameters. You need to identify the hyperparameters for the grid sampling. Which hyperparameter sampling approach should you use? A. Uniform. B. Clog normal. C. Choice. D. Normal. Correct answer is C. Choice. Here's why. Grid sampling requires you to explicitly enumerate the possible values for each hyperparameter. In Azure ML, the choice sampling method is used to specify a discrete set of values, e.g., choice 2, 4, 8, for num_hidden_layers. Methods like uniform, normal, or clog normal are used for random sampling distributions, not grid search. So for grid search over num_hidden_ layers and batch_size, you must use choice. Question 79. You manage an Azure Machine Learning workspace. You build an image recognition training pipeline, which includes hyperparameter tuning. For each epic run, you plan to log the following metrics: the transformed images used for training in an existing folder, a description to explain the hyperparameter changes. You need to configure logging for the experiment. Which two functions should you use? Each correct answer presents part of the solution. Note: each correct selection is worth 1 point. A. MLflow.log_artifact, B. MLflow.log_artifacts, C. MLflow.log_metric, D. MLflow.log_param. Correct answers are B. MLflow.log_artifacts. Used to log multiple files or an entire folder, perfect for transformed training images. D. MLflow.log_param. Used to log hyperparameter descriptions or values, including text, integers, booleans. Question 80. You create a binary classification model. You need to evaluate the model performance. Which two metrics can you use? Each correct answer presents a complete solution. Note: each correct selection is worth 1 point. A. Relative absolute error. B. Precision. C. Accuracy. D. Mean absolute error. E. Coefficient of determination. Correct answers are B. Precision. C. Accuracy. Here's why. Precision measures how many of the predicted positives are actually correct. Useful when false positives are costly. Accuracy measures overall correctness, true positives plus true negatives, total. Common baseline metric for classification. Relative absolute error and mean absolute error are regression metrics, not classification. Coefficient of determination, R², is also a regression metric, not suitable for binary classification. Question 81. You train and register an Azure Machine Learning model. You plan to deploy the model to an online endpoint. You need to ensure that applications will be able to use the authentication method with a non-expiring artifact to access the model. Solution: create a managed online endpoint with the default authentication settings. Deploy the model to the online endpoint. Does the solution meet the goal? T. Yes. F. No. Correct answer is F. Number. By default, managed online endpoints in Azure ML use Azure Active Directory (AAD) tokens for authentication. These tokens are time-bound and expire, so they do not meet the requirement for a non-expiring artifact. To achieve non-expiring authentication, you need to configure key-based authentication, using primary, secondary keys, instead of relying on default AAD token authentication. Therefore, the proposed solution does not meet the goal. Question 82. You are a data scientist using Azure Machine Learning Studio. You need to normalize values to produce an output column into bins to predict a target column. Solution: apply a quantiles normalization with a quantile index normalization. Does the solution meet the goal? T. Yes. F. No. Correct answer is T. Yes. Quantiles normalization transforms data into quantile ranges. Quantile index normalization assigns each value to a bin index based on its quantile. This is exactly how you convert continuous values into discrete bins for modeling tasks. Therefore, the solution does meet the goal. Question 83. You use Azure Machine Learning Studio to build a machine learning experiment. You need to divide data into two distinct datasets. Which module should you use? A. Split data. B. Load trained model. C. Assign data to clusters. D. Group data into bins. Correct answer: A. Split data. Split data, used to divide a dataset into two subsets, commonly training and testing sets. You can specify the fraction for each split, e.g., 70/30ths. Load trained model loads an existing model, not for splitting data. Assign data to clusters, groups data points into clusters, not for splitting datasets. Group data into bins, used for discretization, not splitting datasets. Question 84. You manage an Azure Machine Learning workspace. You have a folder that contains a CSV file. The folder is registered as a folder data asset. You plan to use the folder data asset for data wrangling during interactive development. You need to access and load the folder data asset into a pandas data frame. Which method should you use to achieve this goal? A. ML table. From _parquet files. B. ML table. From _delimited files. C. ML table. From _data lake. D. ML table. Load. Correct answer is B. ML table. From _delimited files. ML table. From _delimited files. Correct method for loading CSV, separated or other delimited text files, into ML table, which can then be converted to a pandas data frame. ML table. From _parquet files. Used for Parquet format, not CSV. ML table. From _data lake. Used for Azure Data Lake sources, not local folder assets. ML table. Load. Loads an existing ML table definition, but does not directly parse CSV files. Question 85. You are using a Git repository to track work in an Azure Machine Learning workspace. You need to authenticate a Git account by using SSH. Which 3 actions should you perform in sequence? To answer, move the appropriate actions from the list of actions to the answer area and arrange them in the correct order. Actions. Generate a public-private key pair. Add the private key to the Git account. Clone the Git repository by using an SSH repository URL. Add the public key to the Git account. Create a new Azure Key Vault resource. Correct sequential answer. Generate a public-private key pair. Step 1. Use SSH keygen in your Azure ML terminal to create the key pair. Add the public key to the Git account. Step 2. Copy the .pub file contents and add it to your GitHub account under SSH keys. Important. You never add the private key to GitHub, only the public key. Clone the Git repository by using an SSH repository URL. Step 3. Use the SSH URL, git@github.com, to securely clone the repo into your workspace. Private key stays on your compute instance, it is never shared. Public key is registered with GitHub to authenticate your machine. SSH URL ensures secure communication between your Azure ML environment and GitHub. Azure Key Vault is unrelated here, it's for secrets management, not Git authentication. Question 86. You manage an Azure Machine Learning workspace. You also manage Azure Blob Storage as a connected data asset. You are creating a photo sharing application in the workspace. Whenever a user uploads a new image to Azure Blob Storage, a scalable processing pipeline must be triggered. The trigger must react in real time. The solution must be serverless. Which 2 services should you use for the implementation? Each correct answer presents part of the solution. A. Azure Functions. B. Event Grid. C. Azure App Service. D. Event Hub. Correct answers are A. Azure Functions. B. Event Grid. Here's why. Event Grid provides real-time event routing. It can subscribe to blob storage events, e.g., blob created, and trigger downstream actions. Azure Functions, a serverless compute service that executes code in response to events. Perfect for lightweight, scalable processing pipelines. Azure App Service, used for hosting web apps, not event-driven serverless pipelines. Event Hub, designed for high-throughput streaming, not direct real-time triggers from blob storage. Together, Event Grid plus Azure Functions give you a serverless, real-time, scalable solution for reacting to image uploads. Question 87. You manage an Azure AI Foundry project. You need to develop a solution that uses an Azure OpenAI service model designed to support reasoning and problem solving. Which model should you use? A. O1 Mini. B. Whisper Circa GPT-4D embeddings. Correct answer is A. O1 Mini. Here's why. O1 Mini, a reasoning optimized model that spends more time thinking before responding. It's tuned for multi-step logic, science, math, and code generation while being more cost-efficient than GPT-4. Whisper, purely for speech-to-text transcription, not reasoning. GPT-4, still very capable, but the O1 series supersedes GPT-4 in reasoning benchmarks according to Azure AI Foundry updates. Embeddings, used for semantic similarity and retrieval, not reasoning. Question 88. You use an Azure Machine Learning workspace. You create the following Python code, *Python from Azure ML. Core import script run config. src equals script run config, source underscore directory equals project underscore folder, script equals train.py, environment equals myenv. For each of the following statements, select yes if the statement is true. Otherwise, select number. Note: each correct selection is worth 1 point. Statements with options. 1. The default environment will be created. Yes. Number 2. The training script will run on local compute. Yes. Number 3. A script run configuration runs a training script named train.py located in a directory defined by the project underscore folder variable. Yes. No. Correct answers are: Statement 1. The default environment will be created. No. Because the code explicitly specifies environment equals myenv, Azure ML will not generate a default environment. A default is only created if no environment is provided. Statement 2. The training script will run on local compute. No. Script run config requires a compute target. It does not default to local compute unless you explicitly set compute underscore target equals local. Without that, the run will not execute locally. Statement 3. A script run configuration runs a training script named train.py located in a directory defined by the project underscore folder variable. Yes. The source underscore directory points to project underscore folder, and the script parameter specifies train.py. This is exactly what the configuration does. Question 89. You use the following code to define the steps for a pipeline. From Azure ML. Core import workspace. Experiment. Run from Azure ML. Pipeline. Core import pipeline from Azure ML. Pipeline. Steps import Python script step. WS equals workspace. From underscore config. Step 1 equals Python script step. Name equals step 1. Step 2 equals Python script step. Name equals step 2 inches. Pipeline underscore steps equals step 1, step 2. You need to add code to run the steps. Which 2 code segments can you use to achieve this goal? Each correct answer presents a complete solution. Note: each correct selection is worth 1 point. A. Experiment equals experiment, workspace equals WS. B. Run equals run, pipeline underscore steps. C. Pipeline equals pipeline, workspace equals WS, steps equals pipeline underscore steps. D. Pipeline equals pipeline, workspace equals WS, steps equals pipeline underscore steps. Correct answers are: A. Create an experiment. Experiment equals experiment, workspace equals WS, name equals my experiment. C. Create a pipeline. Pipeline equals pipeline, workspace equals WS, steps equals pipeline underscore steps. Here's why. To run an Azure ML SDK v1 pipeline, the standard pattern is pipeline equals pipeline, workspace equals WS, steps equals pipeline underscore steps, experiment equals experiment, WS, my experiment, run equals experiment, submit, pipeline. You need a pipeline object right pointing arrow defines the workflow. An experiment object right pointing arrow provides the container for submitting and tracking the run. Question 90. You are using Azure Machine Learning to monitor a trained and deployed model. You implement Event Grid to respond to Azure Machine Learning events. Model performance has degraded due to model input data changes. You need to trigger a remediation ML pipeline based on an Azure Machine Learning event. Which event should you use? A. Run status changed. B. Run completed C dataset drift detected D model deployed. Correct answer is C dataset drift detected. Here's why. The correct event to use is dataset drift detected, because it directly signals that input data has changed and model performance may be degrading. That's the trigger for launching a remediation pipeline. Question 91. You manage an Azure Machine Learning workspace named Workspace 1 by using the Python SDK v2. You create a general-purpose v2 Azure storage account named ML Storage 1. The storage account includes a publicly accessible container named ML Container 1. The container stores 10 blobs with files in the CSV format. You must develop Python SDK v2 code to create a data asset referencing all blobs in the container named ML Container 1. You need to complete the Python SDK v2 code. How should you complete the code? Each correct selection is worth 1 point. Sample underscore dataset equals data, path equals, type equals asset types. Description equals, sample underscore dataset, name equals, sample underscore dataset, version equals, 1.0, options for path WASBSABFSS Azure ML. Options for type, URI underscore file, URI underscore folder, URI underscore ML table. The correct selections are path equals WASBS and type equals URI underscore folder. This ensures the dataset asset references all CSV blobs in the container. Question 92. You manage an Azure Machine Learning workspace named Workspace 1 by using the Python SDK v2. The default data store of Workspace 1 contains a folder named sample underscore data. The folder structure contains the following content: ML table, file 1.txt, file 2.txt, file 3.txt. You write Python SDK v2 code to materialize the data from the files in the sample underscore data folder into a pandas data frame. You need to complete the Python SDK v2 code to use the ML table folder as the materialization blueprint. How should you complete the code? Each correct selection is worth 1 point. Import ML table TBL equals ML table. Choose type, choose path, df equals tbl.to underscore pandas underscore data frame. Options for function, load save take. Options for path, sample underscore data, ML table, / sample underscore data / file *.txt. The key phrase is, use the ML table folder as the materialization blueprint. ML table. Load expects the folder containing the ML table file, not the ML table file itself. This is a common exam trap. Do not choose ML table. Load, sample underscore data, ML table. Choose ML table. Load, sample underscore data. So the correct answers are function, load, path, sample underscore data. Question 93. A team trains an MLflow model that scores customer churn risk. The model will be consumed by different downstream systems. One system requests predictions synchronously during customer interactions. Another system submits files containing millions of records for scheduled scoring. You need to deploy the model by using managed inference options that match each usage pattern. Which option should you use for each usage pattern? Each correct selection is worth 1 point. Managed inference options. Requirement: low latency synchronous predictions. Batch endpoint. Job-based training pipeline. Real-time endpoint. Registered model artifact. Requirement: high volume scheduled scoring. Batch endpoint. Online endpoint with autoscaling. Managed compute cluster. Model registry version. Correct answers are: low latency synchronous predictions equals real-time endpoint. Real-time endpoints are designed for low latency, synchronous scoring during live customer interactions. High volume scheduled scoring equals batch endpoint. Batch endpoints are optimized for large datasets and scheduled scoring jobs, making them the right choice for millions of records. Question 94. Your model requires access to external APIs using sensitive credentials during inference. You must ensure credentials are not exposed in code, logs, or environment variables. What should you implement? A. Hardcode credentials. B. Store in config files. C. Use Azure Key Vault with managed identity. D. Encrypt credentials locally. Correct answer is C. Use Azure Key Vault with managed identity. Here's why. Azure Key Vault securely stores secrets, and managed identity allows your model to access them without embedding credentials in code, logs, or environment variables. This is the recommended best practice for secure credential management. Question 95. Multiple teams need access to approved models with version tracking, lineage, and governance controls. Models must be discoverable and reusable across projects. What Azure Machine Learning feature should you use? A. Blob storage containers. B. Model registry. C. Git repositories. D. Data lake. Correct answer is B. Model Registry. Here's why. The Azure ML Model Registry is designed to store, version, and manage models with governance, lineage, and discoverability across teams and projects. Question 96. A pipeline step fails intermittently due to transient compute issues. You need to improve reliability without modifying core logic or increasing costs significantly. What is the best approach? A. Increase compute size. B. Enable retry policy on pipeline step. C. Run pipeline manually. D. Remove failing step. Correct answer is B. Enable retry policy on pipeline step. Here's why. Retry policies are designed to handle transient errors automatically. They improve reliability without changing the core logic or significantly increasing cost. Question 97. You are performing feature engineering on a dataset. You must add a feature named city name and populate the column value with the text London. You need to add the new feature to the dataset. Which Azure Machine Learning Studio module should you use? A. Edit metadata. B. Pre-process text. C. Execute Python script. D. Latent Dirichlet allocation. Correct answer is C. Execute Python script. Here's why. The Execute Python script module allows you to write custom Python code to manipulate the dataset. You can add a new column named city name and populate it with the value London for all rows. This is the most flexible and appropriate way to perform feature engineering in this scenario. Question 98. You use Azure Machine Learning to train models across multiple experiments by using the same workspace. You must record training runs in a centralized location to compare results from different jobs. During training, performance values must be captured so they appear in the experiment run history. You need to configure experiment tracking. What should you configure for each requirement? Each correct selection is worth 1 point. Requirements and options. Requirement. Ensure runs are recorded in the workspace experiment history. Data asset. MLflow tracking URI. Azure Monitor Workspace. Requirement. Record performance values during model training. Prompt flow. Model registry. MLflow metrics logging. Correct answers are 1. Ensure runs are recorded in the workspace experiment history. Choose MLflow tracking URI. Here's why. Configuring the MLflow tracking URI ensures that all training runs are logged centrally in the Azure ML workspace experiment history. 2. Record performance values during model training. Choose MLflow metrics logging. Here's why. MLflow metrics logging captures performance values such as accuracy, loss, or AUC during training, and makes them available in the experiment run history. Question 99. You use the Azure Machine Learning SDK v2 for Python and notebooks to train a model. You use Python code to create a compute target, an environment, and a training script. You need to prepare the information to submit a training job. Which class should you use? A. Command. B. ML client. C. Endpoint connection. D. Build context. Correct answer is A. Command. Here's why. In SDK v2, you use the command class to define a training job, including the compute target, environment, and training script. This prepares the job specification that can then be submitted with mlclient.jobs. Create _update. Question 100. You have an Azure AI Foundry project with a connected Azure OpenAI service model. You have a set of text files stored locally on your computer. You must set up a flow that will generate responses based on the content of your local files. Which 4 actions should you perform in sequence? Actions. Create a vector index. Create a flow. Create a data asset. Create an Azure AI Search resource. Create a connection. Correct answers are 1. Create a connection. Connect Foundry to the Azure OpenAI resource, and to Azure AI Search if applicable. 2. Create a data asset. Upload your local text files into the project so they can be managed and indexed. 3. Create a vector index. Build a semantic index from the data asset to enable retrieval augmented generation. 4. Create a flow. Design the flow that integrates the connected OpenAI model with the vector index to generate responses grounded in your files. Question 101. You manage an Azure Machine Learning workspace. You plan to train a natural language processing (NLP) text classification model in multiple languages by using Azure Machine Learning Python SDK v2. You need to configure the language of the text classification job by using automated machine learning (AutoML). Which method of the text classification job class should you use? A. Set_data. B. Set_featurization. C. Set_sweep. D. Set_training_parameters. The correct answer is D. Set_training_parameters. Because that's the method in the text classification job class where you configure the language for AutoML text classification jobs. The key phrase is configure the language of the text classification job. In Azure Machine Learning AutoML for NLP, the language is a training parameter of the text classification job. You configure it by using the set_training_parameters method. The other methods have different purposes. Set_data configures the training and validation datasets. Set_featurization configures feature engineering settings. Set_sweep configures hyperparameter tuning. Set_training_parameters configures training settings such as the language. So the correct answer is D. Set_training_parameters. Question 102. You have an Azure Machine Learning workspace that includes an ML compute cluster and a batch endpoint. You clone a repository that contains an MLflow model to your local computer. You need to ensure that you can deploy the model to the batch endpoint. Solution. Add a compute resource to the workspace. Does the solution meet the goal? A. Yes. B. No. Correct answer. B. Number. Here's why. The workspace already includes an ML compute cluster, a batch endpoint. These are the compute resources required for batch deployment. The missing piece is not another compute resource. Since the model is only stored on the local computer, you must first register the MLflow model in the Azure ML workspace, or reference it as a local model during deployment. Create a batch deployment for the existing batch endpoint using that model. Adding another compute resource does not help deploy the model. Question 103. Drag and drop question. A team deploys a classification model to production and monitors performance and data changes. The team wants to ensure that significant drops in prediction accuracy automatically trigger the following. Stakeholders must be notified of the drops. Retraining must be initiated when thresholds are exceeded. You need to configure monitoring to meet the requirements. Which 4 actions should you perform in sequence? To answer, move the appropriate actions from the list of actions to the answer area and arrange them in the correct order. Actions provided. Enable scheduled or event-based retraining. Manually inspect prediction logs after failures. Define performance thresholds for monitored metrics. Configure alerts to notify stakeholders. Monitor baseline metrics from production traffic. Correct 4 actions in sequence. 1. Monitor baseline metrics. Start by tracking production traffic to establish baseline performance. 2. Define performance thresholds. Set thresholds for accuracy or other monitored metrics to detect significant drops. 3. Configure alerts. Ensure stakeholders are notified automatically when thresholds are breached. 4. Enable scheduled or event-based retraining. Automate retraining when performance drops beyond defined thresholds. Excluded action. 5. Manually inspect prediction logs after failures. Not part of the automated monitoring workflow. Manual inspection is reactive, not proactive. Question 104. Note: this question is part of a series of questions that present the same scenario. Each question in the series contains a unique solution that might meet the stated goals. Some question sets might have more than one correct solution, while others might not have a correct solution. After you answer a question in this section, you will not be able to return to it. As a result, these questions will not appear on the review screen. You manage an Azure Machine Learning workspace. The Python script named script.py reads an argument named training_data. The training_data argument specifies the path to the training data in a file named dataset1.csv. You plan to run the script.py Python script as a command job that trains a machine learning model. You need to provide the command to pass the path for the dataset as a parameter value when you submit the script as a training job. Solution: Python script.py dataset1.csv. Does the solution meet the goal? A. Yes. B. No. Correct answer. No. The script expects an argument named training_data, but the proposed command only passes a positional argument, Python script.py dataset1.csv. In Azure Machine Learning command jobs, named arguments are typically passed using the parameter name, for example, Python script.py training_data dataset1.csv, or the script must explicitly read positional arguments. Since the question specifies the script reads an argument named training_data, simply passing dataset1.csv does not guarantee that the parameter is bound correctly. Therefore, the solution does not meet the goal. Question 105. You train models on GPU-enabled clusters but deploy them on CPU-based endpoints. Recently, inference failures occur due to incompatible dependencies. What should you do to ensure consistency? A. Use same compute for training and inference. B. Define and reuse environment configurations. C. Increase endpoint compute size. D. Use batch endpoints. Correct answer is B. Define and reuse environment configurations. By defining an environment, Docker image plus Conda dependencies, and reusing it for both training and inference, you ensure consistent dependencies across GPU and CPU clusters. This is the recommended approach in Azure ML docs. If you found this video helpful, please like and subscribe to InstaLearn AI for more Microsoft AI-300 Machine Learning Operations Engineer Associate exam preparation videos. Thanks for watching, and I'll see you in the next one.